Now we're going to start chapter 3, chapter that is about linear equations and inequalities in two variables. That chapter starts on page 209, and we're going to go directly to the next page, page 210, to work on section 3.1, which is about graphing linear equations in two variables. So this is important, graphing. So we used some graphing on the last chapter when we were dealing with the linear equations, and especially when we were working with inequalities, linear inequalities in one variable. If you remember, we used the real number line to show the solutions for some inequalities, but we can also use the real number line to show the solution for a linear equation. So for example, if you end up with x equals 2, you can plot that solution on the real number line. So you just look for number 2 on your number line. So you're going to draw a full dot, a point, and this is going to be the solution, the graphical solution corresponding to x equals to the graphical representation. And also, if you want to get them, you obtain the solution for a linear inequality being x less than -1, for example, and you want to graph this solution, you just need to look for the boundary. The boundary is at -1, so you look here and you see that -1 is here. You check the inequality symbol and you see that this is the symbol that corresponds to an open boundary. So you're gonna get an empty dot there, and then looking at the symbol again, you're gonna see that the solution region is gonna be to the left of this point. So you're gonna highlight that, and you're gonna draw an arrow indicating that anything to the left of this point is going to be the graphical representation for this linear inequality. And remember, the open circle, the open dot means that this value, x equals -1, is not part of the solution for this inequality. So this is when you are working with linear equations or inequalities in one variable. That variable usually is x. It can be y, z, or other variable. Now in this chapter, we're going to work on linear equations and inequalities in two variables. So we're going to need a different system to plot, to graph the solutions. So we're going to have now two variables. Most of the time, we're going to use just x and y, but it can be other letters. It can be u and v. And we're going to use a Cartesian coordinate system, which also is named a rectangular coordinate system, which is just this plane with these two real number lines, one real number line for x, another real number line for y. And every point in this system is going to be represented by using two numbers now. A number that is going to be the x coordinate, then a comma, then another number for the y coordinate. So the rules or the steps or the recommendations for you to graph a point with coordinates x and y are going to be the following. These are the steps, or this is one of the procedures, because you might find a different procedure in your book or you might have learned a different way to do this. But to graph a point x, y, so a point with coordinates x and y, you're going to start at the origin. So the origin is the intersection point for these two number lines. So that's the origin. Usually the origin has coordinates 0, 0. So you're going to start there, and then you're going to read the coordinates. You're going to read the coordinates as directions for a journey that you're going to take. So these are just directions for you to get your final destination. So you're gonna move x units horizontally. So the first value corresponds always to x, and that indicates that you're gonna shift horizontally. And the second move that you're gonna have is gonna be a move on y. It's gonna be y units vertically. So always this is gonna be a horizontal shift or move, and this is always a vertical shift or move. So if you have your x positive, you're gonna move to the right. If you have your x negative, you're gonna move to the left. And also if you have your y positive, you move up. If you have your y negative, you move down. So with these instructions, with these steps, we're gonna solve one example. And actually the example is just plotting a lot of points, and then you're gonna do the same thing. So let's start then with example 1. So example 1 is on page 211. So it's just the following. You're gonna plot the points, and these are the points. I'm going to write the points here in a vertical format to translate the directions. So the first point is point A. We're gonna use capital letters to name points. So point A is just a point with coordinates -3, 5. Then point B is gonna be a point with coordinates 2, -4. C is a point with coordinates 5, 0. Then D, -5 and -2. E is gonna be 0, 4. And finally F is gonna be 0, 0. So these are the points that we're gonna plot on the Cartesian coordinate system. So the first thing is we need to translate the directions into words for us to simplify our job. So the first point, remember, this is the x value, and this is the second value. This is a horizontal shift, so these are horizontal shifts, these are vertical shifts. So in the first case, you're gonna move first in the x direction, so you're gonna move 3 units to the left, because x is negative, and then you're gonna move 5 units up. So that's the only thing you need to distinguish when what is the coordinate that corresponds to the horizontal move and which one is the one that corresponds to the vertical move. In the second case, you're gonna move 2 units to the right and 4 units down, because now y is negative. Okay, in the next case, so you're gonna move 5 units to the right and no vertical move, and no vertical move. So you stay where you got. So then in the next case, you're gonna move 5 units, but this time you're gonna move to the left because x is negative, and 2 units down because y is also negative. In the next case, you have 0 for x, so no move in the horizontal direction, and 4 units up. And finally, in the last one, no horizontal move and no vertical move. Since you start at the origin in all these cases, in the last case, you just stay at the origin. So remember, starting at the origin, you're gonna perform these moves, and then you get to your final destination, and that's the location for the corresponding point. So it's better if you use a grid paper, so you can download a file that is on Canvas, is right after the syllabus. So, and you're gonna find a grid paper like this, so you can print your grid paper, and that's better when you are trying to graph. You can do that on your notebook, but sometimes you're gonna get some errors because of the difficulty to get accurate at graphing. So let's follow the directions and then get the points. So this is gonna be my grid paper. So I'm going to start with the first point. Point A is you start at the origin. So we start here. Okay. So this is the origin. So it says that we're gonna move 3 units to the left and 5 units up. So 3 units to the left is just 1, 2, 3 units to the left, and 5 units up. So 1, 2, 3, 4, 5. So this is gonna be the end of the journey. So this is gonna be my point A. And I'm going to label the point with a capital A. Then in the second case, we have to start again at the origin. We're gonna move 2 units to the right, 1, 2 units to the right, and 4 units down. So 1, 2, 3, 4 units down. So this is my point B. Then we have, in the next case, we start again at the origin. We're gonna move 5 units to the right. So 1, 2, 3, 4, 5 units to the right, and then no vertical move, so we stay there. So this is gonna be point C. Then we have point D. We start at the origin, we move 5 units to the left, so 1, 2, 3, 4, 5 units to the left, and then 2 units down, so 1 and 2. So we're gonna end up here. So that's my point D. Then point E, we start at the origin, and we know that there is no movement in the horizontal directions, and then only 4 units up. So 1, 2, 3, 4 units up. So we're gonna end up here. So this is point E. And finally, for point F, no horizontal move, no vertical move, so you stay there. So this is point F, which is also capital O, which is the origin. So that's the origin, and that's also point F for this problem. So now you're gonna work on this. So I'm going to give you an assignment. So, and again, you need your grid paper to take your screenshots and send me your work. So you're gonna work now on some problems from 3.1 exercise set on page 220. So what you're gonna do now is you want plot the points that are indicated in problems 10. So let me see the problems. Problem 10. Okay. We need to write the problems first. So it's 10, 12, 14, 16, 18, 20, 22, and 24. And then you're going to have 4 problems where you're going to need to get the coordinates of the points of the given points. So now you're going to need to look at the coordinate system, and you're going to find the coordinates. These are problems 26, 28, 26, 28, 30, and 32. So I'm going to show you the book. So first, for problems 10, 12, 14, 16, 18, 20, and 22, and 24, you have here the coordinates. So these are the coordinates that you're going to plot, this column: 10, 12, 14, 16, 18, 20, 22, and 24. So these are the, you can also plot these ones if you want to practice more, right? So these are the points that you're going to plot. Then you're going to need to look at a graph and find the coordinates for the points that you see in this graph. So this is the graph. So, okay, I think you can see now the graph. Or maybe I need to leave the book for you to see the graph better. Okay, it's hard. So maybe you need to put the book here, and you just need to find the coordinates for points A through G. So let's see if I can increase the size for you to see better. So I'm going to put the projector here. Okay, maybe you can see now better. So that's the problem that you're gonna solve. Find the coordinates of the points that you're looking at the screen. So I'm going to give you time to work on this, and then we're gonna continue with our lecture. So now we're gonna work on solutions of equations in two variables. First, we're gonna test possible solutions, and then we're gonna learn how to find the solution. So this is on page 212. So to test possible solutions, what we're gonna do is we're gonna evaluate the equation for the given values of the two variables. So we're gonna work example 3 now. So example 3 is on page 212, and the problem says that we're gonna determine whether each order pair is a solution of the equation x minus 4y equals 14. So this is the given equation. This is the linear equation. And we want to know whether, for example, 2, 3 is a possible solution. So we want to know whether this order pair is a solution for this equation. So we did this before when we were testing solutions for linear equations in one variable. We're going to do the same now. So remember the order of the coordinates. This is x and this is y. So this is the proposed value for x, that's the proposed value for y, And all together, we want to see whether these two values yield a true statement when you do the substitution. So we're going to start then evaluating. That's the way that we test the solutions. So we're going to evaluate x minus 4y equals 14, 4x equals 2, and y equals negative 3. So we're going to perform two substitutions. So we're going to replace x with 2, and we're going to replace y with negative 3. So that's what we're going to do. If we get a true statement at the end, then that means that the ordered pair is a solution. So let's do that. So we're going to write here 2, because x is equal to 2, minus 4 times, then y is going to be negative 3. So I'm using parentheses, especially when you have negative numbers, and this should be equal to 14. We're going to check whether this is true or not. So we're going to do the operation. So we're going to start with this product. So we have 2, negative times negative is going to be positive. 4 times 3 is going to be 12. So now you just need to complete the computations. So we have 2 plus 12 is going to be 14. Here we have 14. So yeah, this is true. So yeah, this is a solution of the equation. 2, negative 3 is the solution for this linear equation. In other words, this is a line on the Cartesian coordinate system, and this is a point that is on the line. So that's a solution. Any point on this line is a solution. Any point that is not on this line is not a solution. Okay, the next part of this example is going to be part B. And now we're going to test whether 12,1 is also a solution of the same equation that we just mentioned. So we're going to evaluate again the same equation, x minus 4y equals 14, 4x equals, remember the first value x is x, the second value is y, so x equals 12 and y equals 1. That's the evaluation that we're going to perform. So that means that now we're going to replace x with 12 and y with 1. So let's do that. We're going to get 12 minus 4 times 1 equals 14. So let's check. So 12 minus or negative times positive is going to be negative. 4 times 1 is going to be 4. 12 minus 4 is going to be 8. And I have 14 here. So there is not true this. So 12,1 is not a solution of the given equation, x minus 4y equals 14. So graphically, this is going to be a point that is not on this line. So now you're going to work another exercises from the same exercise set. So you're going to go and check 3.1 exercise set on page 220, and you're going to determine, so the directions are going to be the same. You're going to determine whether each ordered pair is a solution of the given equation. So you're going to work 3 problems. Problem 38, the equation is y equals 4x, and you're going to test the following values. You're going to test the following order pairs, 3, 12, then you're going to test 12, 3, then you're going to test -5, -20, Then you're gonna work problem 42. Problem 42 is y equals a minus 4x. Here you're gonna test points a0, 16, -2, and 3, -4. And finally, you're gonna work on this equation x plus 5y equal to 0. So that's my linear equation in two variables. And you're gonna test point 0, 0, then point 1, 1/5, and finally 2, -2/5. So these are the problems that you're gonna work on. So at least send me your answers, your work for the last two problems. I'm going to give you again 10 minutes to work on this, and then we're gonna continue with our lesson. Now we're gonna start graphing linear equations. So we're gonna have 2 or 3 methods to get the visual or graphical representation of a linear equation. So these techniques are very important. You're gonna learn the 3 of those techniques, but later you're gonna be able to choose the ones that you understand better. So, but now we're gonna start with the first method. So we're gonna do graphing. We're gonna get the graph of a linear equation by using the point plotting method. This is described on page 214. And the idea is that you just need to find 3 to 5 points by choosing values for x and then computing the corresponding values for y. So our linear equations are going to be of 2 forms usually. So you're going to have in one form, you just have y equals then a coefficient multiplying x plus a constant term. So this is y equals mx plus b. This is one way that you're going to find the linear equation. Another way, you're going to have both variables x and y on the left-hand side of the equation and the constant term on the right-hand side. So in the first case, you have only y on the left-hand side. In the second case, you have both variables on the left-hand side. So we're going to need to build a t-table. So a t-table is just a table where you're going to summarize your procedure of getting the points. So you're going to choose values for x. So usually 3 to 5 points, 3 to 5 values of x, -2, -1, 0, 1, 2. But this is totally arbitrary, so you can choose any values of x. Usually you choose 0, 1, and -1 because they are easy to handle when you are doing computations. Then you're gonna compute the corresponding values for y. How? You're gonna evaluate the linear equation. So you're gonna write eval and then the corresponding linear equation that you have, either in this way or in this way. You're gonna write that here, and then you're gonna say for x equals, and then you're gonna start doing this evaluation for every value of x that you have. So you're gonna start with -2 first, then you're gonna use -1, then 0, then 1, and then 2. So you're gonna perform 5 evaluations or 3 evaluations depending on how many values of x you decided to work on. Then once you do the evaluation, you're gonna end up with a linear equation in one variable. That variable is gonna be y, so you're gonna need to solve for y. Once you find the value for y, once you find the solution for y, then you're gonna write this value on the second column on the corresponding row, depending on what value of x you are working on. So I'm going to solve one problem step by step, and then you're gonna need to do the same thing with another 3 or 4 problems. So let's start with example 6. So this example is on page 215. So we have example 6 on page 215. 15. So we're gonna graph the equation y equals 3x minus 2. So this plotting method is very useful when you are working with equations where you have your y already on the left-hand side of the equation. So this is for the equations that are of the type y equals mx plus b. So this method is very, very helpful. So I'm going to create a t-table then. So my t-table is just a table with two columns. The first column is for x's, so I'm going to just work with x equals -2, x equals 0, and x equals +2. Only 3 values, because I'm going to repeat the process 3 times. So you're gonna see how to do this. So again, we need to find y. So to find y, we need to evaluate the equation for every x. So to find y, evaluate the linear equation for each value of x. For each value of x. If you have 3 values, you're gonna do 3 evaluations. You have 10 values, you're gonna do 10 evaluations. So I'm going to start with the first one. Then I'm going to start evaluating y equals 3x minus 2. So I'm evaluating my equation. For x equals, I'm going to pick the first value. X equals -2. So I'm doing the evaluation for this x. So how do you do the evaluation? The same way that we have been doing that so far. We're gonna replace x with -2. So we have y equals 3 times -2 minus 2. So you have y equals 3 times -2 is positive times negative is going to be negative. 3 times 2 is going to be -6. Then we have -2 here. So we need to combine these two constant terms. This is the addition of two negative numbers. So when you have two negative numbers, you add the absolute values. The absolute values are 6 and 2. If you add them up, you get 8. And then you keep the sign of those values because you are adding negatives, your answer should be negative. So we got -8 for this y. So we're going to write -8 here because we use this x. So we're going to this thing, we're going to put that value there. Now we're going to continue with the next evaluation. So we're going to evaluate again our equation y equals 3x minus 2 for x equals, and now it's the turn for x equals 0. So we're going to write 0 here. So now we need to replace every x with 0. So we're going to get y equals 3 times 0 minus 2. Any number multiplied by 0 is just 0. So we're going to get 0 minus 2. So at the end it's just -2 because in addition or subtraction, 0 is nothing. So now we need to write this -2 here. So that's the other value that goes here. And finally, we have a third evaluation to work on. So we're going to evaluate the same equation again, y equals 3x minus 2 for x equals, and now the last value I'm going to use is x equals 2. So I'm going to write here x equals 2. So this is the final substitution. So I'm going to replace the x that I have here with 2. So we do that again. So y equals 3 times 2 minus 2. So y equals 3 times 2 is going to be 6 minus 2. Y equals 4. So that's the last value we need to write here. I need to write 4. Okay, so I have now my t-table complete. So I'm going to write the t-table here to get the points. So my t-table is -2, -8, 0, -2, and 2, 4. So this is like having 3 points. The first one is -2, -8, 0, -2, and 2, 4. So the next step is you need to go and work on a grid paper to find the 3 points. The important thing is that these 3 points should be aligned. If you see that the 3 points are not on the same line, then there was a mistake. So you need to verify your work again. So you need to start over. Usually it's better if you start over, because if you try to work your work by finding the error, you're going to take a long time, and sometimes we're going to miss again the error. So I'm going to plot the line here. So the 3 points are -2, -8, that's the first point, 0, -2, and 2, 4. So I have here my grid paper. So I'm going to have my origin here. I'm going to plot only 3 points. So the first one, you can just label A, B, and C. So first we start at the origin, we move left 2 units, 1, 2, and 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. So my first point is going to be here, and that's point A. Then I have point 0, -2, so 0, no horizontal move, only 2 units down, 1, 2. So that is going to be point B. And finally, the next point is at coordinates 2, 4, so 2 right, 4 up. So that's my third point. So now the crucial part, I need to be sure that my 3 points, this is one, this is the second one, and this is the third one, that they are on the same line. So you're going to need a ruler. So this is my ruler. So, and then you're going to use a line. So this is my ruler. Okay. So this is my ruler. And we used to put arrows on the ends to indicate that the line goes to positive infinity and to negative infinity. So that's the line. The 3 points are on the same line. So yeah, you need your grid paper. So I'm going to assign you just a line that you're going to plot, and then we're going to move on to the next section. Okay. So for this section, you're going to work on 3.1 exercise set. So this is the last exercise corresponding to the section. This is on page 221. And you're going to plot, that's exercise 62. So you're going to plot the linear equation with the following equation. So that's y equals 2x minus 1. So plot this line. So I'm going to give you 10 more minutes. Do it carefully. If you want to practice a lot the evaluation and how to build a t-table, choose 5 points, -2, -1, 0, 1, and 2. Get the corresponding y's and then plot the points on a grid paper. We're going to start section 3.2 now. This is about graphing linear equations using intercepts. So this is going to be the second method that we're going to use to get the visual representation of a linear equation. So we're going to use intercepts. So to find intercepts, you just need to follow the following procedure. To get the x-intercept, you set y equal to 0 in the linear equation, and you evaluate that equation to find the value of x. If you want to obtain the y-intercept, then you set x equal to 0 and evaluate the equation to obtain the corresponding value of y. So when you are trying to plot a linear equation by using intercepts, you're going to use a t-table, a very small t-table. With these two values, you're going to set x equals to 0 to find the y-intercept, and you're going to set y equal to 0 to find the x-intercept. So here, you're going to get the y-intercept, and here, you're going to obtain the x-intercept. So I'm going to work example 4 for you, and then you're going to be able to plot a lot of lines. This is a method that is very useful when you have the linear equation in the second form that I mentioned before. So example 4 is on page 227, and we're going to graph 3x plus 2y equals 6. So this is for the case when you have the linear equation expressed as ax plus by equal to c. That is the case when you have both variables x and y on the left-hand side. So if you have a linear equation with this form, then use this method, the intercepts, to find the equation. So we're going to create a small t-table, and we're going to set 0, 0. So to find the values, we're going to start with the first case. So in this case, we're going to evaluate our equation 3x plus 2y equals 6 for x equals 0. For x equals 0, because we have 0 on the first column, the column that corresponds to x. So that means that we're going to replace x with 0. So this is just 3 times 0 plus 2y equals 6. So 3 times 0 is just 0. So you end up with 2y equals 6. And to find y, you just need to divide by 2 both sides. So you're going to get y equals 3. So the y-intercept then is here, is the point with coordinates 0, 3. So that's the y-intercept. Now, to find the other value, we're going to perform another evaluation. So now we're going to evaluate the same equation, but now y is 0. So the second column is 0 in this case. So you're going to replace now y with 0. So you're going to get 3x plus 2 times 0 equals 6. So this term vanishes. So you end up with 3x equals 6. You divide by the coefficient, so you get x equals 2. So that's the x-intercept. So you're going to write here x equals 2. So now I have two coordinates. So I have 0, 3, that's the first point, and 2, 0, that's the second point. So these are the coordinates for the y intercept, and these are the coordinates for the x intercept. Then we just need to go and plot this on a Cartesian coordinate system. So we're gonna find these two points and get the line. So before getting the graph, I'm going to show you something. When you use the intercept method, you're gonna replace 0 in both cases. So the best way to see that substitution is, for example, when you're gonna set x equals 0, that means that you're gonna remove the term that contains x. So it's like putting your finger on top of the equation, hiding the term containing x, and you read the rest. You just can read 2y equals 6. So 2y equals 6 is what you need to work on. 2y equals 6 is this equation, 2y equals 6, that you just need to divide by 2, which is the coefficient of 2, and you get 3. The same thing, when you're gonna get the x-intercept, you need to hide the y term. So if you put your finger on top of the y term, you can read 3x equals 6. So you read 3x equals 6, which is this equation, 3x equals 6. Then you know that you just need to divide by 3. So it's very fast, the way that you can get the intercepts, and then the graph is also very, very easy to obtain. So I'm going to show you then the corresponding graph. So in this case, we are working a problem that corresponds to page 5. So this is going to be 5A. So the points that I'm going to plot, the intercepts, are 0, 3 and 2, 0. So this is the x-intercept, this is the y-intercept. So you just need to find your origin first. The origin is here. We're gonna plot the first point is 0, 3. So 0 in x, no horizontal move, just 3 up. 1, 2, 3 up. So that's the first point. That's the y-intercept. This is the y-intercept. The y-intercept is the intersection of the line with the y-axis. Then the other point is 2, 0. So you move 2 units horizontally, 2 to the right, and then you stay there because there is no vertical move now. So this is the x. This is the x-intercept. So the x-intercept is always the intersection of the line and the x-axis. Now you just need to join these 2 points, and that's the graph of the line. So you're gonna get something like this. So that's the line. So that's the line corresponding to example 4. Now you're just gonna work on a similar problem. And then we're gonna move to the next section to finish our lecture today. So let me give you the problems that you're gonna solve. So this is exercise set 3.2 exercise set. So this is on page 231. So you're gonna graph using intercepts. So I have 5 problems for you. So I think it's very easy for you to do all of them. But at least I'm going to ask you to solve 3. So the first equation is just x plus y equals 6. Then the next one is 24 is 6x minus 2y equals 12. Then we have 28 is 2x minus y equals 5. Then 32 is going to be 10y equals 60 minus 40x. And finally, 40 is 3x minus 2y equals negative 7. Negative 7. So you're going to work on these 3 problems at least. So work on these problems. I'm going to give you 10 more minutes or 15 more minutes to take your time. And then we're going to end up with the next section to finish our lecture. Now we're going to end our lecture today by working on section 3.3, which starts on page 234 and is about the slope. So this is a very important feature of a linear equation. This is a quantity that we're going to deal with a lot of times. So the slope is just a measurement of the inclination of a line. It's a number that says how steep a line is. So if you have a line here, this is a line, straight line, and you can have 2 points on top of that line. You can use those 2 points to find these 2 quantities, the run and the rise. So the rise is just the vertical displacement and the run is just the horizontal displacement. So, and you can use these 2 quantities to indicate how steep a line is, so to find the inclination. So the slope is defined as the rise over the run. In other words, is defined by the change, the vertical change over the horizontal change. So delta, this Greek letter is a capital D, is the corresponding, is the capital D in English. This delta means change, means the difference between 2 quantities. So when you have 2 points, let's say this is point 1 and this is point 2, and you have the coordinates. So let's say that x1, y1 are the coordinates for the first point, and x2 and y2 are the coordinates for the second point. Then you can find the difference of the y's and the difference of the x's. And if you divide the difference of the y's by the difference of the x's, you're gonna get the slope. We use the lowercase m most of the time to indicate, to refer or to denote the slope. Don't forget using parentheses, especially if you are using your calculator to do computations, because in that way you're going to prevent a lot of mistakes that I have seen that the students make when they don't use parentheses and they use their calculators to find this fraction. So I'm going to solve a couple of problems. So these are just problems that we're going to need to see, and then we're going to continue the next time with more, with the third way to get the graph of a linear equation. We're going to need to be able to find the slope, or to understand the concept of a slope, to be able to graph by using the third method. So I'm going to work on example 1 on page 235. So the directions are that we're going to find the slope of the line passing through each pair of points. So in the first case, we have a line passing through -3, -1, and -2, 4. So these are 2 points on the coordinate system. So there is a line passing through these 2 points. We want to know the slope. So this is like having a graph. You don't need to plot, but I'm going to show you what we want to find. So -3, 1, 2, 3, -1. So that's my first point. -2 and +4. So 1, 2, 3, 4. So this is like the line is passing through these 2 points. So to find the slope, first you're gonna label the coordinates. This is important to prevent mistakes. So what are the labels? You can set this as your first point and this the second point, or in the other way. It doesn't matter. But let's say this is gonna be x1, y1. This is gonna be x2 and y2. Another error that students make most of the time is that they label the first 2 coordinates as x1, x2, and then y1, y2. Don't do that. You need to pair an x and a y. So x1, y1, okay? So once you have the labels, you're gonna use your formula. So you're gonna have m equals y2 minus y1 over x2 minus x1. So now this step is crucial. You can see here a negative sign that is part of the formula. And you can see here negative signs that are part of the coordinate. So be careful. You need to keep the negative sign that is part of the formula and also write the negative sign that comes with the coordinate. So in this case, I'm going to have y2 is 4. So I have 4 here, minus from the formula. This minus is from the formula. And then y1 is -1. So there is another minus that comes with the coordinate. I'm doing this kind of notation for you to see the 2 minuses, the one that comes from the formula and the one that comes with the coordinate. Then we close the parentheses. Now, x's, x2 is -2. Then I have this minus that comes from the formula. Then x1 is gonna be -3. Okay? So now you can see a lot of minuses here. So let's simplify this. So I'm going to write 4, then minus times minus, so negative times negative is gonna be positive, and then they have the 1 here. So these 2 minuses, one affecting the other, become a positive sign. The same thing here, the -2 stays there, but this negative times negative is gonna be positive, and then 3 now is going to be very easy to finish this problem. So this is the important thing. That's where the students make most of the mistakes, is when they don't are taking care of the negative sign that comes with the formula, and also that there are negative signs that come with the coordinates. So now you're going to get 5 here, and -2 plus 3 is going to be +1. So the final answer is 5. So this line that you see here, the line that is we're gonna find if you use get your plot, this line has slope 5. So the slope is positive. So all the lines that go in this way are positive, and all the lines that we're gonna have in the other way are gonna be with negative slope. So the sign of the slope and the graph, they match with respect to the with respect to the slope. So now the final part, we have another pair of points. So we have now the points are -3, 4, and 2, -2. So these are another pair of points. So we're going to label. So we can label in the other way. So you can say now that this is x1, and this is going to be y1, and this is going to be x2, and this is going to be y2. It doesn't matter as long as you match an x and a y. Then the formula says y2 minus y1 over x2 minus x1. So let's start. y2, 4, minus from the formula y1 minus 2. So there are two minuses again here. Then x's, x2, -3. So check your labels. x2 is -3, minus from the formula. Then x1 is +2, so you just write number 2. No need to write anything else. So now let's simplify this. This is going to be 4 plus 2, sorry. 4 plus 2, and this is just -3, -2. So this is going to be 6 over -3, and -2 is just -5. You are adding two numbers that are negative. You are adding two negatives. So this is the slope. So if you plot these 2 points and do it, you're going to get a line that is going to have an inclination that is going to be negative. So that's example 1. I'm going to solve one more example, and then I'm going to give you the final set of problems to complete your assignment corresponding to classwork 3A. So this is example 2. That is on page 236. So that's example 2. Page 236. We're going to find the slope of the line. Find the slope of the line passing through each pair of points. So it's a similar problem. So first we have 5,4 and 3,4. So first labels: x1, y1, x2, y2. So 4 labels. Then formula: y2 minus y1 over x2 minus x1. So substitution: y2, 4, minus from the formula, minus y1, just 4. Then x2, 3, minus from the formula, then x1 is just 5. So we get 4 minus 4 is 0. Then 3 minus 5 is -2. So 0 divided by any number, 0 divided by any non-zero number is going to be always 0. So when the slope is 0, then we have a horizontal line. So anytime that we have the slope equals 0 is the case when you have a horizontal line. So in other words, the inclination is 0. No inclination at all is on the ground, so to speak. So now B, we have 2 more points, 2,5 and 2,1. So again, this is x1, y1, x2, y2. So then we use our formula, y2 minus y1 over x2 minus x1. So we're gonna do the substitution now. Y2 is 1, minus from the formula, y1 is 5. Then x2 is 2, minus from the formula, and then 2 is the other x, is x1. So now 1 minus 5 is just -4, and now 2 minus 2 is 0. Now we have the case where the denominator is 0. Anytime that your denominator is 0, the answer is undefined. So anytime that the denominator is 0. And what kind of line is this? This is a vertical line. When you get the slope equals infinity or undefined, then the line is vertical. So this is a vertical line. So M is undefined. Okay, so I think it's time for you to work on finding slopes using the formula, especially taking care of the minuses. So this is going to be 3.3 exercise set on page 241. So you're going to find the slope of the line passing through, or the line passing through each pair of points. And also you're going to indicate whether the line rises. That's when the slope is positive. Falls. That's when the slope is negative. Is horizontal. That's when the slope is 0. Or is vertical. That's when the slope is undefined. So we have the following problems too. The coordinates are 2, 1 and 3, 4. Then we have problem 4, -1, 3 and 2, 4. Then we have problem 6, that's -1, 3 and 2, -1, no, that's not problem 6. Problem 6 is 4, -1 and 3, -1. Then we have problem 8 is 6, -4 and 4, -2. And finally problem 10 is 3, -4 and 3, 5. So these are your 5 problems. So I think you need to turn in all of them because this is important. Understanding the concept of a slope, because we're going to use that concept to work on the third method to graph linear equations. And we need to know how to graph a linear equation because that's going to be the way that we're going to solve linear inequalities in 2 variables. So this is the end of the section. This is the end of the lecture, sorry. So prepare all your work, take screenshots by using CAM scanner or PDF scanner and submit your work on classwork 3a by clicking on the submit button. If you have questions, just send me an email indicating the number of the problem and number of the page, and I try to respond as soon as possible.